Welcome. My name is Alena Naiakshina and I will present the paper on conducting security developer studies with computer science students, examining a password storage study with computer science students, freelancers and company developers. And I would like to thank my co-authors for their contribution. Ecological validity is a major concern in usable security studies with developers. And recruiting professional software developers in sufficient numbers is pretty challenging. So therefore, many studies are conducted with students out of convenience. Motivated by large security breaches exposing millions of user passwords, we wondered, why do developers get password storage wrong and what they think of secure password storage on their own? In order to investigate these research questions, we conducted a qualitative and a quantitative study with computer science students of the University of Bonn. The study findings showed that all the students who were not explicitly asked to store user passwords securely stored them in plain text in the database. These studies were published at the CCS and SOOPS conferences 2017 and 2018. However, some students claimed that they would have stored user passwords securely if they were working for a real company. To examine whether the results were a study artifact, we conducted a follow-up study with freelance developers who received a real job offer on freelancer.com. The findings showed that freelancers and students behaved similarly with regard to their password storage practices. This study was published at CHI last year. One question remained though. Do professional developers employed in companies behave similarly as well? In order to investigate this research question, we conducted a follow-up study with developers employed by different companies. In contrast to the freelancers, we informed the company developers that they were participating in a study because it was not realistic to hire them for the rather small programming task. As in the previous studies with freelancers and students, company developers were asked to implement a user registration code for a social networking platform. We examined the same independent variable that was investigated in the previous studies with students and freelancers. Half the participants were explicitly asked to store user passwords securely, while the other half were told that the study is about API usability. In addition to that, we tested a second independent variable, framework. In the previous study, students had to use either Spring or JSF to solve the task. While Spring offers helping libraries for secure password storage, with JSF, participants had to decide how to securely store user passwords on their own. Freelancers only use JSF, so they were not considered for a framework sample comparison. We wondered whether APIs with different levels of support would affect company developer submissions. So we asked them to either use Spring or JSF. For code evaluation, we used a security scale of 0 to 7 points according to the used parameters for hashing and salting. We used the term secure very loosely for submissions where user passwords were at least hashed. Please use the security score for evaluating how secure the solution really was. Now I will introduce the study procedure of the previous studies and this study. Students had to complete the programming task and then to fill out a survey. Freelancers also had to complete the programming task. However, if they submitted solutions where user passwords were stored in plain text, they were asked to revise their submissions. This request was called SecRequest-P. For company developers, we used the same procedure as in the study with freelancers. Additionally, we added a further SecRequest-G. If submissions scored less than 6 of 7 points, we provided participants NIST and OWASP guidelines and asked them to improve their submissions by following these guidelines. For the sample comparison, however, we used the initial submissions of all the samples. 36 company developers were recruited for the study. Each participant was compensated with 400 euros. All the participants were from Germany. On average, participants were about 37 years old and almost all of them were male. Of the 36 participants, 15 worked for companies with less than 500 employees and 21 worked for companies with more than 500 employees. On average, participants had about 13 years of programming experience in general and about 9 years in Java. First of all, I will report the results of the company developers. For the initial submissions, participants required an average of 8 days. 11 stored user passwords in plain text and those received SecRequest-P. On average, they needed 1.5 days to submit their revised solutions. 17 participant submissions scored less than 6 of 7 points, and thus they were provided NIST and OWASP guidelines. They needed on average 4 days to revise their submissions. In the exit survey, we asked participants how long they actively worked on the task. They reported an average of 7 hours. Now let's have a deeper look into the initial solutions of company developers. 18 participants used Spring and the other 18 JSF to solve the task. 2 non-prompted participants in each framework group at least hashed the user passwords. From the prompted group, 9 participants submitted the secure solution by using JSF and 11 by using Spring. By using Spring, participants achieved higher security scores than with JSF. Spring participants received on average 1 point more than JSF participants. None of the participants received all the 7 points for security. The differences were significant for both variables, prompting and framework. 11 participants submitted solutions where user passwords were stored in plain text, so they received a security request. Only non-prompted participants submitted plain text solutions. After they were asked to securely store user passwords, all but 1 participant submitted secure solutions. By using Spring, participants achieved about 3 points more for security than participants using JSF. Additionally, 17 submissions scored less than 6 of 7 points, and thus participants received the SecRequest-G with NIST and OWASP guidelines. Of the 17 participants who received SecRequest-G, 7 stated that they used OWASP, 3 participants stated that they used NIST, and another 3 participants stated that they used both information sources to improve their submissions. The OWASP information source provided a code example of Argon 2, the winner of the password hashing competition. We found 6 Argon 2 submissions obviously copied and pasted from OWASP, which we were able to identify based on the presented comments in the code. Most participants who received the SecRequest-G were from the JSF group. This can be explained by the fact that participants from the Spring group were able to use Spring's default library with the hash algorithm bcrypt, and thus most of these participants received 6 points. Still, with SecRequest-G, some participants from both framework groups were able to achieve all the 7 points for security. Now I will report the results with regard to the sample comparison. As the figure shows, prompted participants submitted more secure solutions than non-prompted participants, regardless of their status. Additionally, prompted company developers submitted more secure solutions than prompted freelancers or students. Consequently, prompting was associated with approximately 30 times higher odds that participants' solutions would include secure storage of user passwords. In comparison with company developers, students were about 0.1 times as likely to store user passwords securely. Considering the security score of prompted participants, with about 3 points more, company developers who received significantly higher scores than students or freelancers. Overall, prompted participants received on average about 3 points more than non-prompted participants for security. In comparison with company developers, students received on average about 2 and freelancers 1.5 less points for security. Although the previous results indicated that company developers performed better than students or freelancers in absolute terms, they also suggested that all samples behaved similarly in relative terms. A summary of all tests across the different samples revealed that prompting and framework showed a significant effect in all tested samples. Neither Java nor user password storage experience showed a significant effect in one of the samples. So what are the takeaways of these results? Our study findings showed that company developer and students' results differed in absolute terms. That means that company developers submitted more secure solutions than students, and they also achieved higher security scores than students or freelancers. However, in relative terms, the results were similar in all tested groups. For the framework variable, that means that the security scores for the framework Spring were better than the scores for the framework JSF, a result which was observed for students and company developers. Moreover, prompting versus non-prompting had an effect on students, freelancers, and company developers. We believe that these are promising findings since if the usable security and privacy community is concerned about how a new system improves the state of the art rather than which group performs best, our findings indicated that security developer studies with computer science students can offer valuable insights without the need of recruiting professionals. Thank you very much.